Vector search becomes much harder when filters matter. MongoDB Atlas Vector Search lets you combine semantic retrieval with metadata constraints in one production-style workflow. You'll see how to connect the pieces into a workflow that boosts semantic matches with metadata filters for consistent document picks. I'm Professor Pi, teaching Search and IR with simple Python. Hybrid retrieval is where semantic understanding meets business rules. Teams want the best semantic match, but they also need to obey simple constraints like region, year, or product line. If a semantic engine serves results from the wrong region, the business loses trust fast. Atlas Vector Search puts vector similarity inside a database that already knows your metadata, so you can ask for semantically close documents that also pass policy checks. At a high level, success looks like stable, reproducible hits. That means predictable latency and consistent filters across vector and lexical paths. We will build a tiny demo that seeds a small collection, creates a combined vector and text index, runs a filtered vector query, runs a filtered text query, and then blends those scores. The goal is to see how filters prune candidates and how weighting changes outcomes. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. First, we seed a tiny, clean collection, so later filters and similarity are easy to observe. This snippet sets up the absolute minimum dataset we can use to explore Atlas Vector Search behavior without the noise of stale rows. Engineers often wonder whether lightweight seeding can still capture realistic metadata and tag structure for hybrid experiments. So we start by explicitly clearing the collection with call.deleteMany before writing fresh documents. Each insert carries region, year, tags, and a toy embedding so that later filters and distance calculations have meaningful fields to work with. We keep the embedding short but structured so cosine similarity remains intuitive and fast during demos. The print statement confirms we have exactly 3 clean documents ready for subsequent search stages. With documents in place, we must ensure Atlas is indexing both vectors and fields the way the query expects. This code tackles the big production worry. Is the Atlas cluster actually indexing both vectors and metadata, so filters won't fail silently? We feed create search indexes, a vector search definition that wires the embedding path plus filter slots for region and year. Then add a lightweight text index for titles. Listing the search indexes through PyMongo verifies the configuration without having to leave the notebook or click through the UI. Adjusting the similarity metric, or dimension count here, must match the embeddings we stored earlier, or queries will error at runtime. The printed index list tells us MongoDB accepted both index builds, so hybrid queries can execute against them. Now we try a vector-first pipeline that applies the business rules early, so we do not score irrelevant candidates. This example answers the question every hybrid RAG engineer asks first. Can vector search obey the same metadata gates the business rules require? The pipeline pushes the vector search stage up front, passing both region and year filters, so Atlas prunes candidates before scoring. We keep num candidates modest at 6 to avoid latency spikes, but still allow the ANN stage to retrieve more than the final limit of 2. The $project stage surfaces vector search score, so we can inspect how sharply the filter narrows the winner. Increasing num candidates typically improves recall, but with higher CPU cost, while lowering it makes the response faster, but risks missing near matches. The printed line shows our filtered top match and its similarity score, confirming the region year mask held. Next, we do a clean lexical search that obeys the same filter. so we can compare literal matches to semantic ones. This snippet spotlights the lexical side of the hybrid story. How do we lock keyword matches to the same compliance boundary the vector query used? The $search stage employs a compound clause, so the must array targets the title text, while the filter array enforces region equality, which is lighter than post-filtering after aggregation. Returning only 3 rows keeps memory overhead small and mirrors the top case semantics will blend later. If you widen the filter or raise the limit, Atlas can return more textual variants, but the hybrid combiner must work harder to reconcile them. The printed result shows the best compliant lexical document and its score, confirming the filter removed out-of-region hits. Finally, we combine the 2 result sets and inspect how weighting alters the winner. This code tackles the pragmatic decision of how much trust to place in dense versus sparse signals once both obey metadata filters. We initialize a score ledger from vector hits, so ANN similarities get first-class weight, then layer in lex hits with set default to ensure documents that only appear in text search still enter the race. Sorting by score and title for stability exposes exactly how the 0.6 versus 0.4 weighting shifts the winner. Increasing vector weight biases towards semantic similarity, even if the keywords are weaker, while boosting text weight makes literal matches dominate. The summary print shows which document wins after blending and what its combined score looks like, highlighting the trade-off engineers can tune. If you take this tiny demo into a product, treat the 3 documents as a focused slice of a larger corpus. The same pattern scales. Seed representative records. Create matching vector and lexical indexes. Run filtered vector candidates. Run filtered lexical candidates, and then blend. Instrument num candidates and weight choices as you grow the dataset so you can measure latency and recall trade-offs. Recap. Hybrid retrieval in Atlas runs vector and lexical searches under the same metadata constraints inside the database. Use this when business rules must strictly filter results while you still want semantic matches. One caveat: tuning candidate counts and weights matters because they change recall and compute cost in opposite directions. Next step: tune vector weight and text weight across a validation set while tracking latency and top K accuracy so you find the sweet spot for your use case. If practical IR that respects policies helps your product, subscribe and watch the rest of the IR videos.